Hello and welcome to this video. This is a new unit, Unit 7 on probability. It's going to be very short, only 2 lessons. This is our first lesson. We're going to talk about experimental and theoretical probability. Let's get started. So like I said, this unit only has 2 lessons. Our second lesson after this one, we're going to talk about permutations and combinations. Since this is our last week, it's a very short unit, so let's go ahead and dive in. In this lesson, we will cover independent and dependent events, calculating probability. We'll do some practice examples, and then I'll leave you off with the IXL work. All right, let's talk about independent versus dependent events. So 2 events are considered independent if the probability or the outcome of one doesn't affect the outcome of the other. But they're considered dependent if they do affect one another. An example of an independent event would be like flipping a coin, because each time you flip the coin, it doesn't change the next time you flip the coin. Or something called drawing with replacement. Suppose you had a deck of cards. If you pull one card out and then you put it back in, that's the replacement part. Your probability doesn't change the next time you pull out a card. But a dependent event would be something like drawing without replacement, where you pull out a card, but then the next time you draw a card, you don't put that card back in, and so now your probabilities have changed. So the first event affected the probability of the second. When you calculate probability of independent events, you find the probability of the first, and then you multiply it by the probability of the second. However, if you have dependent events, you need to find the probability of the first, and then multiply it by the probability of the second given, this little symbol means given, the first event. So the probability of the second event given the first event. That's if the 2 events are dependent. Let's try an example. Diane picks a marble at random and puts it back. So that's your key word there. If you're ever saying puts it back or replaces it, then you know it's going to be an independent. And then picks another marble at random. Are these 2 events dependent or independent? Our answer here is independent, because when she puts it back, the next round is not going to be affected by the first one. Alright, let's try this question. At a fundraising event, Nicholas is drawing raffle tickets to determine winners. Nicholas has already drawn a ticket. So he's already pulled it out for the first prize and will draw a name for the second. So he hasn't put it back. So therefore, these 2 events must be dependent. The probability of the second depends on the first. Alright, you flip a coin twice. What is the probability of getting tails and then getting heads? Write your answer as a percentage. So first we need to decide, is this independent or dependent? This is going to be independent because you're flipping a coin and each outcome doesn't affect the next one. So we need to find the probability of the first outcome and then multiply it by the probability of the second. So the first outcome we want to get is the probability of getting tails. So the probability of getting tails is the same as probability of getting heads, 1/2. Then we find the probability of getting heads, which is also going to be 1/2. And this can also be written as 0.50. And then we just need to multiply these 2 things to find the probability of getting tails and getting heads. So 0.5 times 0.5 is going to give us 0.25, and we need to write that as a percentage. To write it as a percentage, just move the decimal place to the right 2 times, and you get a 25% chance. Alright, suppose you pick a card at random without putting the first card back, so that's how you know these are dependent, because you're not putting it back, there's no replacement. You pick a second card at random. What is the probability of picking a prime number and then picking a prime number again? Simplify your answer, write as a fraction. Alright, so these are dependent events. So we need to find the probability of the first and the probability of the second given the first has occurred. Okay, the probability of the first of picking a prime number, let's see, 5 is prime and 7 is prime. And there are 5 in total. So the probability of a prime number, let me just write, probability of a prime number is going to be 2 out of 5. Now the second thing is you've pulled a card out, one of the primes. Now there's only 1 prime left. So the probability for the second pulling is changed. So probability that the first card is prime, probably the second card is prime given the first card we pull is prime, is only going to be 1 out of 4. Because now we only have 4 cards total and only 1 of them is prime. Now we just need to multiply these 2 things, 2 over 5 times 1 over 4. Multiply straight across. 2 times 1 is 2. 5 times 4 is 20. And we can simplify that to be 1 over 10. We're going to leave it as a fraction because that's what they asked us to do. Alright, so that's it for these IXL questions. If you want more of a challenge, check out the extension activity on the Google Classroom titled Conditional Probability Extension Questions. Here's the IXL for y'all to work on, Geometry X3. So please be sure to send me an email or join me during my office hours on Zoom with any questions. Best of luck.